Ladies and gentlemen, allow me to extend a warm welcome to our 8th Allianz Autotag, which this year for the first time will be broadcasted digitally and live all over Europe. Our topic today is IT security in connected vehicles. Though bicycles may be gaining more and more appeal, the car is and will remain Europe's most popular primary means of transportation. The characteristics of today's vehicles have changed. They used to be isolated systems with an engine, but now they are computer networks on wheels equipped with an internet connection. Millions of lines of software code along with control devices and sensors are making the new concepts in mobility, comfort and driving safety possible. These innovations are paving the way for highly automated driving. And just as traditional computer networks became a target for cyber attacks, vehicles are likewise increasingly exposed to cyber risks. Alongside the logistics and energy sectors, connected cars may become one of the most important targets for IT crime, because the number of connected vehicles will be increasing significantly in the next few years. In Europe alone, the IT service company Capgemini projects an increase from 37 million connected cars in 2018 to 110 million by 2023. This means that while IT security in connected cars is becoming even more significant, it is also presenting a challenge because vehicles are goods with an extremely long useful life. From the viewpoint of IT security, the life cycle of a vehicle model from development, production to use and recycling is 20 to 30 years. That stands in sharp contrast to two things: the enormous speed at which computer performance is expanding and the concurrent shrinking use cycles of consumer electronics. The particular challenge is to keep the level of protection and security of connected vehicles from going down throughout the vehicle's life cycle to the advantage of hackers, because their hacking methods continuously evolve. Secure means suitable protection from vehicle theft, vehicle damage, and unauthorized data access. But most of all, keeping the car's occupants and other road users safe. I'd like to take a look here at 6 aspects of a car's life cycle. 1, the many people involved in development and production. 2, standards and requirements for type approval of vehicles in Europe. 3, security by design in development and after delivery. 4, secure access to vehicle data. And 5, hacking attacks and networking do not stop at national borders. 6, the future need for action. Let's look first of all at the fact that the development and production of high-quality connected vehicles and the future highly automated models involve many people. And they are involved all along the value chain and throughout the vehicle's life cycle. This includes people involved in the departments at the vehicle manufacturers themselves, along with their suppliers at all levels, the telecommunications industry, and the software companies and developers who are engaged not just in the product's creation, but also in the services and products that only come into play once the vehicle is in operation. Here, manufacturers have to orchestrate countless digital interfaces that can otherwise open up gateways for hacking attacks. 2, standards and requirements for type approval of vehicles in Europe. Requirements and standards are currently being defined that will establish the prerequisites for vehicles to be approved for road use in the European market. In June, the UN ECE World Forum for Harmonization of Vehicle Regulations drafted detailed requirements for managing cyber risks and over-the-air software updates. These will be supplemented, probably in November 2020, by the ISO standard 21434, Road Vehicles Cybersecurity Engineering. As a result, vehicle manufacturers will have to meet detailed requirements in many areas, including organizational requirements and certified processes, and monitoring of and responsiveness for events even after the vehicle's production period. This will create a technical standard for automobile development, which makes it possible to document compliance with the expected rules for vehicles types approval. As we see it, these are important steps in the right direction. They can't guarantee that vehicles won't be hacked, but they make an important contribution to minimizing cyber risks. 3, security by design in development and after delivery. Let's have a look at the technical security that plays a key role in development, if only because of the extensive networking of vehicle components. Vehicles may incorporate 60 control devices or more, and each one of them needs to offer adequate security against manipulation in its specific application. For example, if the software on a device that controls the charging and power draw on an electric vehicle can be read out and the parameters can be changed, that offers a gateway for unauthorized tuning. This entails a substantial risk that the battery could overheat, and so it should absolutely be prevented. But even after a car is delivered and handed over, the ability of its system and electronics to work properly must still be guaranteed. Over-the-air software updates are already a reality today, and they allow software security to respond in a way that used to be possible only by taking the car into the shop. Product monitoring and early detection of attacks on a vehicle by the vehicle manufacturer's security operations centers will also have to contribute to the security of connected vehicles. 4, secure access to vehicle data. Secure access to vehicle data is crucial for a working mobility ecosystem, and by that I mean in both directions. A connected car must be adequately protected from cyber attacks, but at the same time, it has to permit discrimination-free access to the vehicle data easily and secure so that third parties can perform servicing. Ultimately, that would be very similar to a smartphone. The operating system is the foundation, but it's the many apps and users that really make a smartphone what it is for the user. As insurer, we too consider ourselves an integral part of this ecosystem. We have a fundamental interest in adequately securing data access and developing practical solutions with the industry. Based on a well-informed risk calculation, we offer services and products for our customers like telematic rate plans, for instance. That includes digital processes that assist in the event of a claim, from acknowledgement and analysis and appraisal to processing vehicle claims using a smartphone. Here, Allianz is relying heavily on prevention and on early recognition of loss scenarios. Using the extensive data about specific claims that we have collected at the Allianz Center for Technology, we remain in close communication with the manufacturers and can help recognize developments early on and exert a positive influence on them. A good illustration of that is vehicle theft. For more than 2 years now, it has been possible to order cars that have a virtual key. That key opens, locks, and starts the car by using a smartphone, which replaces a conventional car key. After a car is stolen, the vehicle's operator has to provide us with the full set of keys when claiming the loss. But how can they turn in a virtual key to the insurer? How can they prove that the vehicle was really stolen and not just being used by an unauthorized driver who somehow acquired a virtual key at some point? And the insurer has to answer the question, what do we need to investigate and how? So in a joint leadership collaboration with RCAR, an association of automobile research centers from Europe, Asia, North America, South America, and Australia, we helped to define an international standard for virtual vehicle keys so that we can compensate our clients quickly and without complications after a total theft, even when a virtual key was used. On top of that, to protect our clients, the standard also defines yardsticks for the IT security of the entire system, including the vehicle, the smartphone, the backend, the communications, and user interactions. 5, hacking attacks and networking don't stop at national borders. We are certain that the growing IT risks for connected vehicles can be countered only by a sensible cooperation among everyone involved, and at European level. As was shown by Fiat Chrysler's recall of 1.4 million vehicles after a 2015 hacker attack in the US, thousands of vehicles could also be affected across borders by a single attack in Europe as well. The financial loss from these attacks is great. Recalling all the affected vehicles had cost the vehicle manufacturer $600 million. 6, the future need for action. Given the challenges that hacking attacks and potential pan-European cumulative risks present to the industry, and to us as an insurer, there is a need for action in 2 areas in particular. 1, it must become possible to detect hacker attacks on individual vehicles and fleets quickly and early on. First of all, that involves fending off the attacks, but it also entails determining possible damage. In line with what we discussed at the 7th Allianz Autotag about the use of vehicle data to investigate accidents in automated driving, we also believe that it's necessary to recognize and record cyber attacks. Storing them with an independent data trustee, where only technical data and no personal data is transmitted, could comply with data protection laws and both cover the involved parties' needs for information and enable the development of appropriate loss statistics. This would make the risks to society accessible and calculable. 2, fast detection and response to cyber attacks requires not only company-specific solutions, but also multi-industry, pan-European platform for the companies involved in the mobility ecosystem. To effectively address the challenges I've outlined, we are calling for a European solution at the 8th Allianz Autotag, a multi-industry automobile security information center. We are dealing with a potential threat that doesn't stop at the company walls or national borders, and we believe that such a center needs to combine the competencies of multiple institutions, including government agencies, vehicle manufacturers, automotive suppliers, telecommunication operators, research institutions, the repair industry, and the insurance industry. The primary purpose of an automotive security information center would be to ensure that the mobility ecosystem can prepare for and respond to security threats and incidents so that everyone involved can optimally manage their own business risk and the customer's risk as third parties. Everyone involved can exchange their information, deduce threats from the documented attacks, and then develop steps for individual and joint IT risk management. As an operator, in addition to a public organization, private companies or associations can also come under consideration for this purpose. The collected information about the detected actual events will accumulate in a knowledge database. Having access to this information will be important for the automotive industry, for scientists, for researchers, trainers, and policymakers. This kind of interdisciplinary exchange of information will encourage transparency and thus security as well. In addition, ethical computer hackers, known as white hat hackers, could make a further constructive contribution towards IT security, even outside traditional professional conferences. This group can be expanded with the addition of institutionalized forensics and insurance companies. Ladies and gentlemen, Europe is one of today's leaders in vehicle development and construction. But we'll only be able to maintain that leadership if we are also leaders in IT security for vehicles and the entire mobile ecosystem.